Ever wondered how companies build entire cloud infrastructures with just lines of code? That's where infrastructure as code, or IaC, comes in. It's like writing a blueprint for a house, but instead of bricks and mortar, you're coding servers, networks, and security settings. But here's the catch. IaC isn't just about writing correct code. It needs to work. No bugs, no errors, and no crashes when deployed. Let's break it down. Imagine you're a chef, and you write a recipe for a soufflé. The instructions look perfect. Mix flour, sugar, and eggs, but when you bake it, it collapses. Why? Because the recipe didn't account for oven temperature or mixing time. That's the deployability gap, the difference between code that looks right and code that actually works. This is where AI struggles. Researchers tested top models like Claude-3.5 and GPT-4, and guess what? Over 70% of their first attempts failed to deploy. It's like giving a chef a recipe with missing steps. Sure, the ingredients are there, but the end result is a disaster. The problem? Most AI tools focus on syntax, making sure the code is grammatically correct, without checking if it'll function in the real world. Enter IaCGen, a revolutionary AI framework that learns from its mistakes. Think of it as a chef who tries a recipe, tastes the soufflé, and adjusts the ingredients based on what went wrong. IaCGen uses an iterative feedback loop. If the code fails, it analyzes the error, tweaks the template, and tries again. The result? Success rates jumped from 30% to over 98% in just a few tries. It's like giving AI a built-in kitchen assistant that shouts, "Hey, your oven's too hot." But here's the real game changer, a massive new benchmark called DPIaC-Eval. Imagine a library of 153 real-world cloud scenarios, setting up servers, configuring security, scaling resources, each with a gold standard working template. This isn't just about checking code. It's about testing whether AI can handle the messy, complex realities of cloud infrastructure. What did they find? Syntax isn't enough. Even with perfect grammar, 25% of AI-generated templates failed to match user intent. Security is still a hurdle. Only 8% met all security standards on the first try. Human-AI collaboration helps. When humans provided feedback, accuracy jumped over 19%. This isn't just about better code, it's about building trust. As cloud systems grow more complex, the margin for error shrinks. IaCGen and DPIaC-Eval aren't just tools. They're a roadmap for ensuring AI-generated code isn't just smart, but reliable. But IaCGen isn't the only exciting development. Other researchers are exploring ways to make AI better at coding too. Take CodeSim, where AI practices debugging in virtual environments, like rehearsing for a play. Or DeepSeek-Coder, a model that outperforms general AI by focusing only on programming. It's like giving a chef a cookbook versus a generic recipe app. Sometimes specialization wins. And here's a surprising twist. Even with all this AI power, developers still rely on their own judgment. A 2024 study found that most use AI as a helper, not a replacement, like having a smart assistant for brainstorming, but keeping the final say in their own hands. Plus, new techniques like self-refinement let AI improve its own code, like a writer revising a draft. Combine that with human guidance, and you've got a partnership that's smarter than either side alone. Whether you're a developer, a tech enthusiast, or just curious about AI's role in the cloud, this work shows that the future of infrastructure isn't just about automation, it's about intelligence. Thanks for watching and stay curious.